Well, welcome to this online revision session for AQA D1, in which we'll be looking at the January 2010 question 2 on the topic of sorting algorithms. Well, in this particular question we're looking at the bubble sort in order to rearrange a set of numbers so they are ordered in ascending order. So, how do we start with that? Well, from the initial positions, which we have 13, 16, 10, 11, 4, 12, 6 and 7. So the idea of the bubble sort is that you draw a bubble around the first pair and you compare them. In this particular case, the 13 and the 16 do not need swapping, so the 13 stays where it is. Now you pair the next two, the 16 and the 10, and the 10 needs to swap places with the 16. So now the 16 will now be paired with the 11, and once again the 11 will move up, and then the 16 will be compared with the 4, and the 4 moves up, and the 16 with the 12, so the 12 moves up, and the 16 with the 6, so the 6 moves up, and the 16 with the 7, and the 7 moves up. And so after the first pass we have the number 16 definitely as the largest number at the end of the list. Okay, so that's a pass when the bubble has been completely worked its way through the set of numbers. One pass has been completed, and so we know the 16 is in its correct place. Now we start again at the top doing the same. So we compare the 13 with the 10, so the 10 and the 13 swap places. Then we compare the 13 with the 11, and so the 11 and the 13 swap. Then the 13 with the 4, and the 4 swaps. And the 13 with the 12, and the 12 swaps. And then the 13 with the 6, so the 6 swaps, and the 13 with the 7, so the 7 swaps, and then that's the point at which you can stop, because you now know the 13 is the next to the 16. So now we know that the bottom two numbers are in the right place. So we repeat the 10 with the 11, no swap again. 11 with the 4, yes, we swap. The 11 with the 12, no, we don't. The 12 with the 6, yes, we do. The 12 with the 7, yes, we do. So now the 12 must be in its right place, because the 13 and 16 were in their right places. And so that's the point at which we now know the bottom three are in the right place. So here we go again. The 10 with the 4 swaps. The 10 with the 11, no swap. The 11 with the 6, yes we do. The 11 with the 7, yes we do. And we can stop at that point, because once again the 11 must be in the right place, because the 12 and the 13 and the 16 are definitely in the right places. Now we know we're in the right place up to there. So we compare again, the 4 with the 10, no swap. The 10 with the 6, yes we swap. The 10 with the 7, yes we swap. So the 10 is now in the right place, as well as the 11 and the 12 and the 13 and the 16. So up to the 10 are now all in the right place. So now we compare the 4 with the 6, there's no swap. The 6 with the 7, there is no swap. We don't need to go any further because we know that the 10 and the 11 and the 12 and the 13 and the 16 are all in the right places, and if there were no swaps as we went through that pass, then they must all be in the right places. It's important that you've got this last pass in here. So we've done 1, 2, 3, 4, 5 passes. Just because you can see they're in the right order, remember the algorithm is telling you you've got to carry on checking until there are no passes, so you must have that extra 1 in there to complete the correct number of passes, to complete the algorithm. Okay, so there's 5 marks for this part. So you get a method mark for applying the algorithm correctly in that first pass, and you get an accuracy mark for the first pass being correct. You then get an accuracy mark for the second pass being correct, and an accuracy mark for the third pass being correct, and then you get an accuracy mark that must include those last 2 lines being the same. So that gives you your 5 marks. It then says state the number of comparisons and the number of swaps for each of the first 3 passes. So we want the comparisons and the swaps. So in the first run through, we did 1, 2, 3, 4, 5, 6, 7 comparisons. We didn't swap on the first time, but then we swapped on all of the subsequent ones, so there were 6 swaps all together. The second time through, the number of comparisons will decrease by 1 each time, so that decreases to 6. So there was a swap on the first one, a swap on the second and the third and the fourth and the fifth and the 6th. So there were 6 swaps again, even though there were only 6 comparisons. Finally, on the third run through, there will be 5 comparisons, and if we look at them, there was no swap on the first. There was a swap on the second, that's 1, no swap on the third, and then there were 2 more swaps. So in total there were 3 swaps on that third one. Well, for getting these answers correct, you'll either get 3 marks if you got all 6 of these correct. You would get 2 marks if there's just 5 of them correct, and you only get 1 mark if there's 3 of them correct. Okay, so it's either 3, 2 or 1, depending on how much of it you've got right. Hopefully you found that solution helpful. For more assistance with your maths revision, please go to the Further Maths Support Programme website.